Well, now I'm going to explain you the next method of the separation of the components of the mixture, that is evaporation. Students, in this method, it is used for separating a solid from its solution. That is, for example, salt from its aqueous solution. The solution, it is taken in a china dish, and then we are going to place that dish over a flame. Flame means a Bunsen burner. The water will start evaporating slowly and leaves behind the salt as a residue. Students, while evaporating a solution, a stage comes when the amount of the solvent becomes very little, and this solution is called a concentrated solution. When it is allowed to cool slowly, the crystals of the substance dissolved start separating, and then the process is called as a crystallization. And students, it is used to obtain a substance in the pure state. Now students, let us learn how common salt is obtained from seawater. Right? The method is used on a large scale to obtain a common salt from seawater. As we all know that seawater contains salt, so we can call it as a salt solution. Now seawater is collected in a shallow pits dug on the seashore, and the heat of the sun makes the water evaporate. Now when enough water has evaporated, the solution becomes concentrated. So then the salt begins to crystallize. So the salt is further purified and mixed with a chemical called sodium iodate, and this mixture is called iodized table salt. The sodium iodate, it contains iodine, students. So the lack of the iodine in our diet may cause the disease that is known as a goiter. Now the next method we are going to learn, that is dissolution and evaporation. Students, this method is useful when one component of the solid mixture is soluble in a solvent and other is not. To make it understand more easily, we will take an example. Take a solid mixture of salt and sand in a beaker, and we will add some water to the mixture and we will stir it. And then we will warm it from time to time so that all the salt get dissolved in the water. Then we will filter and wash the residue 4 to 5 times with the hot water. Evaporate that filtrate to the dryness in a china dish, and then we will get a white solid. Right? That solid is what? It is a salt. And the residue on the filter paper is sand, which can be dried in the sun. Now next process we will learn, that is our distillation. Students, in distillation, a liquid is vaporized by being boiled, and the vapors are condensed and collected separately. Now if the liquid were mixed with any solids, the solids would not vaporize. So thus a liquid can be separated from a solid mixed with it. And the process is useful for separating a solid liquid mixture, homogeneous, for example, a solution of salt in water, or a heterogeneous, that is, for example, a sand in water. Students, for the distillation, see the setup I am showing you here. This setup is used while performing this distillation method. Right? The mixture is boiled in a flask, and the emerging vapors are cooled in a Liebig condenser and is collected in a flask. So boys, what is a Liebig condenser? A Liebig condenser is a long tube provided with a jacket through which water is circulated for cooling the vapors in the tube. So this is how we will prepare distilled water in the lab. Now we will learn about the fractional distillation. Students, in the fractional distillation, we can separate liquids which differ in their boiling point by the 20 degrees Celsius or more. The mixture of liquid is boiled in a flask, and the vapors are passed through a fractionating column. The vapors of the liquid with lower boiling point rise, and the vapors of which has a higher boiling point condense in the bulb like traps. Students, please see the setup I am showing you, and when you will see this setup carefully, you are going to understand what I am explaining. The higher boiling liquid may also come back to the flask, and the lower boiling liquid gets into the condenser first and collects in the receiving flask. as long as the lower boiling liquid continues to distill, the temperature remains constant. And after the lower boiling liquid has distilled off, the higher boiling liquid begins to distill and the temperature rises. The receiver is immediately changed and higher boiling liquid is collected separately. So the separately collected liquid are termed as fractions. Students, by fractional distillation, we can separate alcohol, which is having a boiling point of 78 degrees Celsius, from the water whose boiling point is 100 degrees Celsius, and benzene, who's having boiling point as 80 degrees Celsius, from the toluene whose boiling point is 110 degrees Celsius, and the different fractions from the crude oil. So the next method that we will learn for separating the components of the mixture, that is by using a separating funnel. Students, a separating funnel is used to separate two or more immiscible liquids. The mixture is placed in a separating funnel and then it is allowed to stand. The different immiscible liquids, they form a separate layers which can be collected in different vessels one after the other. Now students, so by this method we can separate an oil, benzene, toluene or ether from water. So the next method we will learn, that is our sublimation. Before we should learn what is this method of sublimation, very first we should know what is a sublimation. It is a process in which a solid, it vaporizes without melting. So what are the examples? Ammonium chloride, iodine, naphthalene balls or the camphor. So using this method we can separate a substance that sublimes, for example ammonium chloride, camphor or iodine, from one that does not. That is, we can take sand, salt or a chalk. So let us see the experiment given in your book. A funnel is inverted over a mixture placed in a china dish, and then a dry test tube is also inverted over the outlet of the funnel. See the students.